Hello, everyone. So welcome to Software Quality Assurance and Testing course. This is Module 1, and we're going to talk about Introduction to Testing. We're going to discuss several concepts and case study related to software quality assurance and testing. I hope you get convinced why software testing is important and why we should learn it from this module. All right, let's get started. So first of all, I would like you to pause the video for a minute and think about what does it mean for you to have a good software. So what is a good software like for you? Okay, let's pause it for a minute and then you resume when you are ready. All right. So for many of you, I guess you would say that a good software are the software that have fewest bugs or without any bugs, and it should represent what the software is supposed to do, right? Like if software is supposed to allow the people to buy stuff on the internet, it should work as expected. Okay, so these are some of the quality or some of the characteristics that the good software should have. So the next one is the question of where do we use software? All right, so let's take another minute to think about it, and then you can resume the video after you have finished. All right, which place that you think we use software? Many people might say on your computers, many students might say on your phones, or you might say on your watch, so on and so on. In a house, you have some smart devices. I have a TV at home that is having software running on it. I also have a washing machine that also can control by mobile phone, so on and so on, right? So these are the very basic devices that we can use software on. But there are also some complicated situations and some special location that you can also deploy the software on. For example, an airplane like this. It also runs with multiple software. You can have an autopilot software that run and control the airplanes instead of relying solely on the pilots, the human pilots. The other thing is these kind of plants, like nuclear power plants, that you need to have some software to control its operation. So with these kind of devices or vehicles or plants or buildings, getting the software that is of very high quality is very important because these are mission critical systems. It relates to people's life. It relates to safety of the people. So these are the place where the software must be guaranteed that it has very high quality. And next, I would like to move on to the concept of software quality assurance itself. So what is software quality assurance? Okay, let me start by showing you some of the existing issues that occur in the past that is represented by some software that are not very well designed or developed. Okay, if you remember during the time of the COVID-19, we need to have these systems so that we can reserve the COVID-19 vaccines, right? And most of the systems that allow you to go and book for vaccination, they were not able to accept that so many requests on the first day or even the first minute that it started the operation. And this happens multiple times. So even multiple hospitals, multiple mobile carriers that do this kind of system, they still have the very first problem on the first day. So having a software that is of high quality is not easy. It needs a lot of skills and it needs a lot of design to be able to do that and a lot of testing involved. Also, not only in Thailand, but this problem is spreading worldwide, right? So this is the case where people want to buy the ticket for Taylor Swift concerts, and there's a problem with the pre-sale access ticket, which cause people to waste time, waste their money, and sometimes also has bad impression with the system. So what is software quality assurance? Okay, the software quality assurance is a plan and systematic patterns of the actions that are necessary to provide adequate confidence. Okay, so you want to have the actions that give confidence to the users that the item or the product, it conforms, which means it follows, it complies to the requirements. Okay, so how would you make guarantee or give confidence to your users that the software follows the requirement? The second one is that it's a set of activities that are designed to evaluate the process. Okay, it is designed to check the process which the product are developed or manufactured. So you have a way to check whether that process is good or bad. Okay, this is part of the software quality assurance. The third one is the systematic activities again, that you want to also provide adequate confidence that the entity fulfills the requirement for quality. So this is more of the organization. Okay, so the organization itself also fulfill the requirement to deliver good software. And the last one, that you are giving confidence that not the technical requirements, but the quality requirements. The quality requirements are non-functional requirements like security, scalability, like the case of the vaccination reservation system that we have seen, reliability, responsiveness of the system, so on and so on. All right. So the software quality assurance is pretty broad. It covers starting from requirements to the design to the implementation of the software. And next, I would like to move on some case studies that show us that the software testing is not an easy task. Okay, I will start by this very simple program. The program is a class called the trivial class, and it has only one single method called a sum method. So the sum method receives two parameters, integer a and integer b. It computes the summation of the two values, and then it returns that value as an integer to the user. So this is a pretty simple, one of the most simplest program that you would have with this one line of execution, okay? And if you want to test this program, let's say you are assigned to test this kind of program, how would you test it? Let's assume that we can execute 1,000 test cases per second. So you have one computer that can go through these value that you can put in for A and B. And then that computer can input 1,000 test cases into the method and get the result out. The question is how long it will take to thoroughly test this function. Okay, let me show you what the test case look like. One test case would look something like this. You give A and B, and then you have the expected output. So in this case, if you give A and B, your expected output would be 2. If you give 1 and 2, the expected output should be 3. And if you keep doing this, you can derive so many test cases. If you go to 5 and 5, then the expected output is 10. You can even go to 1,000, and that would be 2,000, so on and so on, okay? You can have a lot of test cases that still cover the value of integer A and B. So the question is, if you want to thoroughly test this function, how long it would take, okay? I will give you a hint that one integer in this Java programming language has the value that it can be 2 to the power of 32 values. Okay, that covers the negative values, the 0 values, and the positive value. All right, so let's pause this video for a bit, and you go to the next slide, and then you can put your computation in. The result needs to be in the number of time. Okay. All right. Have you got the answer? So let's do the computation together. So the number of test cases that we can get from this program would be equals to the value of A, which is 2 to the power of 32, multiplied by the value of B, which is also 2 to the power of 32, right? We have one value of A, we have another value of B, and each value of A can be paired with any value of B. So that is multiplication here. When you do this kind of multiplication, you would get 2 to the power of 64, which is the summation of the power. And if you want to get the time needed, you get these 2 to the power of 64. First, if you divide it by 1000, you would get seconds, right? Because 1000 test cases per second. And the second is still too large, okay? If you, sorry, this is 64. If you go to the calculator, or if you use Google as a calculator and you compute 2 to the power of 64, that's a pretty huge number. So just divide by 1000 is still very large. We can divide further by 60 and then you would get minute. You divide further by 60 and you would get hour, which is still very large. And we divide by 24 and then you would get days. And I have to tell you that we need to go further by dividing it with 365 and then you would get years. All right. So let's see how much, how many years are these? I'm going to put in Google for now. Okay. 2 to the power of 64 divided by this number. What I get is 584942173.55 years. Okay, so that is 5,849 million years. All right, so that's a pretty huge number. Okay, 5,800 million years. That's much more than one people's lifetime. So we cannot finish this testing of the sum method using this machine within our lifetime. So this doesn't work. How would we find smaller amount of tests? But still high quality, enough that we can cover most of the cases. Okay, so that is the key idea for these courses. You learn how to select the amount of test input, which is finite and not so big, which you can run in a practical amount of time, but it's still having high quality and you can cover most of the cases that the software can fail. All right. Okay. So next, I want to tell some stories about existing case study of failures in software system. The first one is the case study from Apple. So Apple had this very famous case study of software failure. It's called Apple Go to Fail. Okay, it is a program of Apple that runs in multiple devices: iOS, OS X, and Apple TV. This is like 10 years ago, more than 10 years ago. It is a function to perform SSL encryption, which is one kind of encryption that you would do when you connect to HTTPS. And the code here that is shown in the slide is from the file called SSL key exchange.c. Okay, you don't need to totally understand what the code do, but please look closely in the part of code and you will see something strange. Okay, and I want you to take 1 or 2 minutes to see what's the problem here and then resume the video to see the discussion about it. All right, I hope you get the answer. I put the arrow here, right? So the problematic lie is here. Let's analyze it a bit. So this is a C program. In C, if you don't have any parentheses after the if statement, okay, if you put a parenthesis, the statement inside those inside the parentheses, how many statements there is, it will be always executed under the if statement. But if you don't have the curly braces, only one statement after the if statement will be executed under the condition of the if statement. And in this case, you will see that the statement that falls into this if statement is only the first one, the first go to fail statement. And this one does not belong to the if statement. So the second go to fail statement is actually on its own. And every single time that the execution occurs, it goes to this if, it go to this if, it go to this if, it go to this if. And then no matter what, the if statement is true or not, it's going to go to the second go to fail statement. And in C programming language, if you have the go to, it is the keywords that tell the execution to jump right to the location of this label fail. So the program might jump somewhere where the fail label is defined, and it skip the rest of the program. Okay, and this create problems because some of the checks here, they are not executed, and that's why Apple has to release a fix, and this has a security number CVE 2014-1266. All right, so this is a problem called Apple Go to Fail, and if the code has been tested well enough, I believe that this kind of problem might got detected. It might caused by some developers forget to delete the line because they might keep copying the line from the previous if statement. So testing would help in this case, such as doing unit tests. The second case study is from the European Union. So the European Union also do space exploration, and they have this rocket called Ariane 5. So Ariane 5 got exploded just a few seconds after it launched. The problem is that when they develop the rocket, they have multiple teams that are working on the software of the rocket. And there's one value that need to be passed around between different modules that are developed by different teams. This one is called horizontal bias. And you can think about it as a value that control the movement of the rocket, right? The first team used the data type of 64-bit floating point value for the horizontal bias. So this is the first team. The second team used 16-bit integer for that same value. So when they are passing around between module 2 and module 1, you get this problem of floating point error because you want to put the value that much larger than the other one, 64-bit to 16-bit, right? So you got a floating point errors and things go wrong. The rocket got exploded just right after it launches. So this create a loss of many million euros, all right? And this kind of problems can also be detected early on if they do sufficient integration tests. The next one is one of the most well-known problem in the past few years. This is a problem of Boeing 737 MAX. Okay, the airplane models Boeing 737 MAX. There are two airplanes that crashes just a month after another, and after they check the black box of the airplanes and analyze everything, they found that some of the problem partially occur because of the software fault. The story is like this. There are two airplane manufacturers in the world, Airbus and Boeing. At that time, Airbus was releasing a new model of the airplane that can fly faster and with bigger engine and so on. So the Boeing doesn't want to lose the competition. So they want to also release a new model to compete with Airbus. What it does is that it doesn't want to change the model because changing the plane model costs a lot. The pilots need to also get recertified to fly the new airplane, and there's a lot of pilots that already know the Boeing 737, which is a very popular plane model for Boeing. So what Boeing does is that it replaces only the jet engine to be bigger, more powerful one. But the model, the body of the plane is still the same. Okay, so let me explain the software that is built into this Boeing 737 MAX. So the software is called Max Flight Control System, or MCAS. And why this software is needed? This is because of when you replace the engine with the more powerful one, but you still use the same body, then you can get a problem of the plane going up, the nose going up. And if the plane going in this direction, you're gonna get a problem called stall or stalling, which means the plane going vertical and then it doesn't have any wind support and the plane is gonna go straight down. Okay, so the max flight control system, or MCAS, is gonna read from the sensor, which is called the angle of attack sensors, that they are on the nose of the plane, and there are two sides of the sensor on each side of the plane. And when it detects that the plane is going up, then it's gonna adjust the tail of the plane, and then it will push the head of the plane down. So when the plane is actually going nose up, and when MCAS is activated, it's gonna keep the plane to head coming back down, and then the plane can go straight. So they thought that the problem is already solved. However, the software MCAS itself has some issues, and it reads only from one sensor on one side. So if the sensor is malfunction, the software also malfunction as well. The second thing is that MCAS is designed not to allow the pilot to override the execution of the software. So when the MCAS is activated, the pilots cannot change that. So if you imagine that the plane is going like this as normal, however, there are some issue with the sensors, and MCAS is thinking that the software is that the just a moment, that the plane is going up, but actually it is going straight as normally. It would start adjusting the tail, and it will keep pushing the plane heads down, and that's where the plane crash occurred. Okay, so this problem actually started from the software that is not well designed and is also not well tested, right? So this system might be able to, we might be able to prevent this kind of problem if the software is fully tested and check that it's supposed to read from both sensors, and also it should allow the pilot to override the execution. Okay, so you will see that from these three case studies, there are many issues that can occur, and especially in the mission critical software systems, the cost could be very high. Like we have loss of lives, or we lost a lot of money for these kind of problems. And there are many case studies that you can continue reading from these provided links. So next, let's move on to this question on why do we test software, okay? Before getting into the detail, I want to explain a bit about the terminologies that we would use in this course. There are three specific levels of problems that could occur with the software. Usually when there are problems with the software, we would call that the software has bugs, right? And bugs can represent any things that go wrong with the software. But we can have more fine-grained explanation of each type of bugs. The first one is called software fault. So software fault is a static defect in the software, which is the wrong part of code that is written by a programmer. The second one is called a software error. So the software error is an incorrect internal state that is the manifestation of some fault in the software. So software fault actually cause software error. All right, let me show you an example here. So let's say if we have this very simple Python program, you read some input from the user and you check whether if X, which is the input that the user put in, is it more than or equal to 0 or not? Okay. So if X is more than or equal to 0, you would say that the number is positive or the number is 0. But if not, then you say the number is negative. Let's say I was the programmer for this program. And what I did is that I forgot to include this equal into the program. Okay. So if you enter value 0 into X, the program would show this output, which is the number is negative, right? So if I put 0, I would get the number is negative. And if I put 1, then I would get the number is positive or 0, okay? So the part that is wrongly written here is the software fault, and it's caused by me that I put in the wrong code. The software executes, and if it gets the input of 0, it goes to the second, it go to the if statement instead of the, sorry, it go to the else statement instead of the if statement. Then this is the software error because it goes to the wrong internal state. Okay, make sense? So the question is, can we have a fault? I mean, can every fault always lead to software error? Let's pause the video and think about it for a minute and then resume to listen to the answer. Okay, so the answer is no. It depends whether that fault is triggered or not. So if you give a fault, if you give the value of 0, the fault is triggered because 0 is the part that I wrongly put the code in, which is a check for 0. Then the software error occurs because the program takes the wrong decision. But if I put other numbers, like in this case, I put the value of 1, the program still go to the correct if statement, and then it still output the correct output. Okay, so to sum up, not every fault leads to a software error. It depends whether that fault is triggered or not. Okay, let's move to the third one. The third one is called software failure. So software failure are external incorrect behavior that respect to the requirement. And it is something that the user can observe or see, right? So if the user has an app and then they see something wrong in the app, that is software failure. It comes out externally so that the user of the program see. So if we go back to this case, we will see that when this value has been printed out, that is a software failure because the user of this program would see that when 0 is entered, the output was wrong. Okay, so I have another similar question. Does every software errors always lead to a software failure? Let's pause the video and think about it and resume when you are ready. Okay, the answer is also no. There are some cases that the software error doesn't lead to software failure. For example, the software error might occur, but it doesn't propagate until the user can see. So in that case, the user doesn't know. There may be some wrong calculations, but the calculation goes to the database and is never show the result to the users. Or the software is supposed to record some information into the log file, but it doesn't do so, and the user doesn't know. So in this case, the software error doesn't lead to a software failure. The software error can lead to software failure in some certain cases. All right. Okay. So next, let's talk about testing.